Okay, so I've got these three questions under calculus. This is advanced calculus. So if you are in college, university, this is your calculus right here. They want us to find the limits. Okay, you can see the limit as x approaches 0 of sine x over x, and also the limit as x approaches 1 over x over ln x, limit as x approaches infinity of 2x over e power x. So here you have to know that in mathematics, when you've got 0 over 0 as the solution, it's not acceptable. Okay, so you have to do something up until you change the denominator, or when you've got anything here. Okay, or maybe let me say you've got 3 over 0, it's also not acceptable. Okay, the denominator cannot be a 0 as a solution. The other one, it's infinity over infinity. It's also not acceptable. So if you're getting your solution in any of the things that you're doing in mathematics as any of these, it means you need to do something. And mostly when it comes to limits, you need to apply what we call L'Hopital. Okay, L'Hopital's rule. So this is the rule what we're supposed to, or which we're supposed to consider or apply. So this is a gentleman who came up with an idea. In case you're finding the limits and you get solutions of this nature, you're supposed to, let me write this. When you've got limit as x approaches a, okay, of some function f of x over g over x. What the gentleman said that if this is giving you a solution, if any of these solutions, you need to change. You need to find, you change this to limit as x approaches a, you find the derivative over the numerator over the derivative over the denominator, okay, which will give you some solution L, okay. So you have to first differentiate the top part. You also differentiate the bottom part, and this is what you're getting. You then plug in the x value. Okay, so let's start with the first question. The first question here says that we find the limit. Okay, we find the limit. This is question 1. Limit as x approaches 0 of sine x over x. So if you are seeing nicely, when we plug in the value of x here, okay, sine 0 over 0, this will simply give us a solution which is a 0 over 0, and this is what we don't want. Therefore, we can apply what we call L'Hopital. L'Hopital says that when you've got such, or you're getting such a solution, get this, the top function, we said f of x, which is sine x. You also get the bottom function, you say g of x, which is equal to x. So when we differentiate this, we shall say f prime. This, of course, is giving us a cos x, while the g of x is giving us what? A 1. What is the derivative of x? Is 1. What is the derivative of sine x? It is cos x. So now, once we do this, we can now come back, or we go back to this. So limit as x approaches 0 of cos x over a 1. So now it has changed. Where there was sine x, we write cos x. Where there was x, we put the derivative there. And this will just be equal to limit as x approaches 0 of cos x. Because I know that cos x, or 1 into cos x, it will just be cos x. Therefore, I can say cos 0, okay, is equal to a 1. So the value of cos 0 will simply be equal to a 1. Okay. We now go to the next question, which is question 2. Question 2, of course, is dealing with the limits. It's dealing with the ln, so to say, natural log. So when you get this limit as x approaches a 1 of x over ln x, this will simply be equal to a 1. When we plug here, we shall get a 1 over ln 1. Now this will give us a 1 over a 0, because the value of ln 1 is equal to a 0. And this, of course, is what we don't want. So we shall therefore say f of x is equal to x, and g of x is equal to ln x. Okay, so now the derivative of f of x here, so we shall write f inverse of x, it will just be equal to a 1, while g inverse of x will be equal to 1 over x. Okay, so that's it. Now from this stage, we can of course apply the limit as x approaches a 1 over 1 over x. You see, you get this, write it here, and this you write it as a denominator. Therefore, this will simply be equal to 1 over 1. When you substitute the value of x here to be equal to 1. And finally, this will give us a 1. Okay. So we now go to the last question, which is limit as x approaches the infinity. So the same here, when you look nicely, this limit as x approaches the infinity, okay, over 2x over e power x. So this will be 2 open bracket x. We are multiplying 2 by the infinity over e power infinity. This will give us infinity over infinity, and this is not what we want. Therefore, L'Hopital's can be applied here. So it will be limit as x approaches the infinity, okay? Or before we do this, let's get the functions. So f of x will be equal to 2x, while g of x will be equal to e power x, all right? So now from here, of course, we can find the f inverse of x, which is equal to a 2, and g inverse of x, which is equal to the same thing here. The derivative of this is just the same. And then we plug in limit as x approaches infinity of, here it will be 2 over e power x. This 2 over e power x. So when we substitute there, we have a 2 over e power infinity, which will just be a 2 over infinity, because e power infinity, it will just be infinity, and any constant over infinity will give us a 0. So this is how these limits or L'Hopital's rule can be used. Thank you so much for watching. This has been Isichamba Jacob. Please remember to like the video, leave a comment, and share. Bye-bye.